Introduction. Hello and welcome to today's session. In this session, we will explore the concept of data and its critical role in the field of information technology. Data is the foundation of virtually all IT systems, guiding decisions, shaping strategies, and powering applications across industries. We will examine how data is collected, organized, and managed through database systems, and why understanding data modeling and management is essential for IT professionals. By the end of this session, you will gain insight into how effective use of data not only supports IT operations, but also drives innovation and efficiency within organizations. Data consists of raw facts and figures collected from various sources. It can be numerical, textual, visual, or audio. In databases, data is stored in a structured format for easy retrieval. Understanding data is crucial for effective management and utilization. This knowledge forms the backbone of IT operations. Data is categorized into structured, unstructured, and semi-structured types. Structured data is highly organized and easily searchable. Unstructured data lacks a predefined format, posing challenges in processing. Semi-structured data contains tags or markers, but lacks full structure. Each type requires specific management strategies. Data characteristics include volume, velocity, variety, veracity, and value. Volume influences storage solutions. Velocity requires real-time processing technologies. Variety encompasses different data types. Veracity ensures data accuracy. Value is derived from analysis and interpretation. IT roles interact with data in various ways. Analysts extract insights from data. Cybersecurity technicians protect data privacy. Software developers design data structures. DevOps engineers manage data workflows. Each role requires a unique data management approach. Data modeling is vital in database design. It visually represents data and its relationships. Conceptual models provide a high-level overview. Logical models detail data types and relationships. Physical models specify storage details. Data drives business decisions and enhances customer experiences. It creates competitive advantages. Effective data management identifies trends and improves efficiency. It enhances security by mitigating threats. Data analysis reveals valuable insights. Open data is freely accessible and modifiable by anyone. Public data is accessible but may have usage restrictions. Both promote transparency and innovation. Examples include government statistics and environmental data. Public data includes weather reports and census data. Private data is confidential and restricted. It includes personal and corporate information. Internal data is used within organizations for operations. It supports decision-making and internal processes. Examples include employee records and operational metrics. Research data is collected during projects and may be open, public, or private. Big data involves large data sets requiring advanced analytics. It is characterized by volume, velocity, and variety. Big data analysis uses machine learning and AI. Examples include social media and IoT sensor data. Structured data is organized and easily searchable. Unstructured data lacks a predefined format. It includes qualitative data types. Storage solutions differ for each type. Examples include customer records and social media content. Semi-structured data contains tags or markers. It combines elements of structured and unstructured data. Examples include JSON and XML files. Storage often involves NoSQL databases. It offers some organization, but lacks rigid structure. Data types include text, numeric, Boolean, date, and time. Structures encompass arrays, stacks, queues, and linked lists. Choosing the right type ensures efficiency and accuracy. It impacts memory usage and performance. Proper selection reduces bugs and enhances scalability. Data classification categorizes data by sensitivity and value. It ensures compliance with regulations. Classification aids in audits and reporting. It protects data integrity and confidentiality. Tailored security measures mitigate threats. Role-based access control assigns permissions based on roles. It minimizes data leakage risks. Segmentation creates distinct access levels. Data usage policies guide handling and sharing. Training increases employee awareness. Correct data types ensure accurate input and storage. They enable proper output formatting. Access to libraries aids data manipulation. Accurate input acceptance prevents data corruption. Input masking and validation maintain integrity. Databases rely on correct data types for field accuracy. Input masking ensures valid data storage. Storage calculation optimizes database efficiency. Appropriate types reduce storage needs. They enhance performance and scalability. Conclusion: understanding data and databases is essential for IT professionals as it underpins the effective design, management, and security of information systems. Utilizing data strategically allows organizations to make informed decisions and achieve greater success. For any queries or assistance, send a WhatsApp to 074 84361 688. Our team will be glad to help. Thank you, and we look forward to seeing you again.